Hello and welcome to Lesson 10. This is the fifth lesson in Unit 2B in our Grade 10 academic math class. This is solving problems using trigonometry, our final lesson and the final part in this unit. So let's get right to it. These are word problems where we're using all the tools at our disposal, including the right angle triangle stuff and the non-right angle triangle stuff. Example number 2. The Queen Charlotte Islands in BC form a fairly triangular region in the Pacific Ocean. Two sides are about 256 kilometers and 288 kilometers and form an angle of 19 degrees. What is the length of the third side? So I've started a sketch here for us. Let's label this a little bit here. So we have, let me get some color. So the two long sides are obviously the 256 and 288. The longer of the two of them here, sort of the base of this triangle, is 288. This long one up here is 256. And the angle is going to be 19 degrees. Just kind of tuck it in there. So here we have it. What are we after is actually this side over here. Let's just pop an X on it. And okay, this is a non-right angle triangle, obviously. And we are going to try to find the length of that third side of the triangle. How are we going to do it? Well, it's either going to be sine law or cosine law. We don't have a side angle pair, so we're going to be using cosine law. Let's start with a let statement. So let X represent the length of the third side. And that's going to be in kilometers, I think. Yep. In kilometers. There we go. All right, so we're going to need a cosine law. Let's set this up. So we have x squared equals, and again, the 288 and the 256, they're interchangeable as far as this goes. So you can put the 256 squared first if you want. Doesn't really matter. Minus 2 times 288 times 256 times the cos of 19 degrees. I typically counsel just banging this whole thing through your calculator. So let's do it. 288 squared plus 256 squared minus 2 times 288 times 256 times cosine of 19 degrees equals, and we've got 9,057.612, etc. Again, I'm not going to write it all down, but I'm also not going to clear it from my calculator, since there's no sense rounding it here if I'm just going to be able to, in one button click, do the calculation. So we are going to take the square root of that value, and it is going to give us 95.17, so 95.2, length of the third side. You know what, let's just round this one to the nearest whole kilometer, since that seems like what they might have done. So we have our 95 kilometers. Let's get a therefore statement on there. Therefore, the length is 95 kilometers. All right. Third side conquered. Let's take a look at the second part of this question. What is the approximate area bounded by the Queen Charlotte Islands? Okay, so here they're asking us to go a little bit above and beyond what we've been doing, which is we are actually being asked to calculate an area. That's okay, we can do that. Let's get the labels back on this thing. So here we had our 19 degrees. Here we had our 256. Here we had our 288. Now, if you recall, the area of a triangle is calculated by multiplying the base times the height and dividing it by 2. So if we look at this triangle, right, we have a base already. That's going to be 288, no problem. But what we're missing is a height, which is why I've already dotted it in here. Now, in order for us to find a height will necessarily connect with the base at 90 degrees, which is cool because that gives us now a little bit of a hint as to where we should be going with this. We're going to be looking at this triangle right here to figure out what the height is going to be. We have a reference angle already. We've got a side. That's all we need. Let's get to it. So let me clean that up a little bit. I'm going to just do some more drawing on here. So there's our reference angle, 19, kind of just colored in a little bit. From 19, the H value is going to be the opposite, and this is going to be the hypotenuse across from our 90. So let's get a let statement happening on this thing. So let H represent the height of the triangle. Represent the height of the triangle. going to measure that, of course, in kilometers. Okie doke. Let's get to the trig part. So we're going to use opposite and hypotenuse. We're going to be using, because we've got a right angle triangle here, we're going to use primary trig ratios. Could we be using sine law and cosine law? Well, sorry, could we be using sine law? Yeah, we could. I'm just going to use the primary trig ratios. Again, it's a nice reminder. So we are going to use for opposite and hypotenuse sine. So the sine of 19 degrees, which is our reference angle, equals our opposite, which is unknown, over our hypotenuse, which is 256. Put that over 1. Let's cross multiply here. And we have h being equal to approximately 256 times the sine of 19 degrees. Let's get that in the calculator and see what we've got here. So h equals approximately 256 times the sine of 19 degrees is going to equal 83.3. It's 83.345. So we'll just go with 83.3. That's kilometers. Okay, and now we can calculate an area. Let's move on to that. So we are going to, let's just keep this maybe a little bit more simple. Let's just, whoops, that's a highlighter. Let's just go with 83 kilometers approximately. That's pretty close. We're talking about kilometers here, so it's not a huge thing. Let's calculate the area. So the area then will be equal to, let's call this number 2, I guess. Find the area. The area then will be equal to 288, which is our base, times 83, which is our height, divided by 2, which is the denominator of the formula. And let's calculate this out. So we've got base 288 times height, which is, now we just want to double check it, 83, good, times 83 equals, divided by 2 equals, and we have 11,952. And now this will be square kilometers because we're talking about area. Let's put a therefore statement on it. Therefore, the area of the triangle is about 11,952 square kilometers. There we go. We got a therefore statement happening. Again, we got sort of multiple steps here. It's nice we got to use some different things. This concludes the unit. So this is the end of our exploration of trigonometry for this, well, obviously for this unit and for grade 10. If you have any questions in the homework, obviously it's more word problems like this where you'll have an opportunity to use all or lots of the tools that we've explored over the last two, like Unit 2A and Unit 2B. If you have any questions, reach out as always via email, get a hold of me in class or through our classroom meetings that we have. Any way you can get a hold of me if you have questions, that's the way to do it. No questions left behind. Good luck with the homework and good luck with the assessment, and I guess I'll see you in the next unit.